So, solving radical equations. Now, most of what we're going to focus on with radical equations are going to be square roots and cube roots. Most of them. Okay? Just because once you get the idea for a square root or a cube root, you'll understand that you can apply it to any other radical also. Now, I want to reflect back to something really quick. When we graphed a square root, remember when we graphed these and you ended up with something like that? Approximately, it could have been flipped or whatever. We had a domain that was dependent on something, right? We had x is greater than or equal to something or x is less than or equal to something. And when we made our xy chart, what happened? We would put our h and our k in the middle, but one side of that h and k we would have to cross off. Do you remember that? Why would we have to cross off? Because it would be giving us imaginary numbers, right? When we graphed cube roots, we got something that looked like this. And what about our domain? It was all real numbers. And when we made our xy chart and we had our h and our k, did we have to cross any numbers off? No, we could go both ways. And that had to do with the fact that our domain was all real numbers, meaning that we could use any x value and get an answer. Up here, we couldn't use any x value. We could only use certain x values because the other ones would give us imaginary. Okay? Now, because of that, there's one small difference between solving a square root equation and solving a cube root equation. And I'm going to take that one step further and say that there's one little difference between solving an equation with an even index versus solving an equation with an odd index. Okay? So keep that in mind because I'll come back to that. All right. In the past, you would have had an equation like this, right? And how would you get x by itself? You would square root both sides, and you would say x is equal to plus or minus 5, right? Yes? Well, this time we're starting with a radical in the problem. So how do I cancel out the radical so that I can get x by itself? Well, if it's a square root, I'm going to raise it to the second power because a second power will cancel out a square root. Now, if I do it to one side, I also have to do it to the other. So that's going to cancel, and I just need to figure out what 25 squared is. 25 squared is 625. It is a big number. Okay? Now, the thing we have to remember is because of this information right here and this information right here, we have a restricted domain here. In other words, it can't be any number, right? It has to be certain numbers. So when I'm dealing with a square root, I actually need to check my answer by plugging it back into the problem to make sure that my answer is in the part of the domain that gives me nice numbers. Cube roots, every x value will work, or every x value that I get as my solution will work. So what does that mean? That means I have to take 625, go back to the original problem, and see, does the square root of 625 equal 25? If that's true, my answer's good. It does, so my answer's good. And we'll see one where it doesn't work out. So all of this to say, when you have an even index, you must check your answer. When you have an odd index, you don't have to check your answer if you're confident you did the work correctly. Okay? All right. Now, that was a very simplified example. Once we get more complicated, we do have to follow some steps here. So step 1 is one of the most important steps, and what does that step say? Get the radical alone, meaning I don't want anything on the same side of the equal sign as the radical. So if I'm looking here, the radical is on the left side of the equal sign. Is there anything on the left side of the equal sign that is not a part of the radical? No. So my radical is by itself, which means I am now ready to raise both sides to a power. What power am I going to raise both of them to? The second power, because the second power cancels out a second root. The power that I raise it to must match the index on the radical. Does that make sense? So if it was a cube root, what would I raise both sides to? The third power. If it was a fourth root, I'd raise both sides to the fourth power, and so on. So let's see. I now have x plus 25 equals what? 16. That's a pretty easy equation to solve, isn't it? Subtract your 25, and I get x equals negative 9. So if I go back and check my answer, let me check it in a different color here. The square root of negative 9 plus 25, does that equal 4? Well, what is negative 9 plus 25? 16. Does the square root of 16 equal 4? Yeah. Yep. So since that works, my answer is good. Why did I have to check my work there? Even index. Even index, you have to check your work. Okay? So there? Good answer. All right. Let's look at these two. What's the difference between these two? One's a square root, one's a cube root. Now, out of curiosity, if you have the square root of something, can it ever give you a negative result? Like if I plug any number into my calculator, if I take the square root of anything, can I get a negative answer? So how's that going to look if I actually solve this out? This one, my radical is by itself, so I would go ahead and square both sides. And that gives me x equals 4. But if I go check that value, the square root of 4, does that equal negative 2? No, because the square root of 4 is 2. That's not true. So what happens if I have to throw out that answer? I have no answer left. What does that mean? No solution here. Okay. All right, what would I have to do here? Is my radical by itself? My radical is by itself. So I can take both sides and I'm going to raise them to what power? The third power. Why the third power? Because it matches the index. Cube root, you're going to cube it. So cube root cancels out a cubed. And I get x equals, what is negative 2 to the third power? Negative 8. Do I need to check this one? Not if I'm confident that I did my work correctly. I'm going to check this one just to prove to you that it's correct. So if I plug this back in, the cube root of negative 8, can that equal negative 2? Because remember over here we said the square root can never equal a negative number. Can a cube root equal a negative number? Yes. Yes. And if I go to my calculator and I say what's the cube root of negative 8, it gives me negative 2 as my answer. So that does check out. My answer is good. Okay? You can always check your answer if you just want to make sure you're doing it right. But you only have to check it on even ones, even indexes. Okay? All right. Moving on. Let's look at this guy. Is my radical alone? No. What do I need to do? I need to divide by 2 and I need to subtract 1. Which one do I have to do first? Subtract 1. That gives me 2 times the cube root of x minus 3 equals 4. Now what? Divide by 2. So the cube root of x minus 3 equals 2. Now is my radical alone? Yes. So what can I do? Raise both sides to the third power. And that gives me x minus 3 equals 8. Add 3, and x equals 11. Do I need to check my answer? No. No. Can I check it if I want to? Of course. So if I just wanted to mentally go in here, 11 minus 3 is 8. Cube root of 8 is 2. Times 2 is 4. Plus 1 is 5. It does check out, which it should. Now, one place where people mess up here. They want to move that 3 here. They want to go from right here and plus 3 on both sides. Why can't I do that? Because it's inside a radical. I can't take something out from inside a radical until I deal with the radical. Okay, so don't try and take out a number that's under a radical until you have either squared both sides or cubed both sides or done the appropriate operation there. So? Okay. One that looks a little different. Okay, what's my first question going to be? Is the radical alone? Is it? Yes, because even though there's a 6, that 6 is part of the radical, right? So, if the radical is alone, I'm ready to square both sides. Now, this is important here. Squaring the right side does not mean that I square the x and I square the 8. It means that I square the whole side. Which means what? I'm going to have to write it twice and like FOIL it basically, right? So here that's going to cancel out. I have x minus 6. Over here I have to do x minus 8 and x minus 8 and multiply that out. Using either distributive method or box method, doesn't matter. So I have x minus 6 equals x squared minus 8x minus 8x plus 64. Yes? X minus 6 equals x squared minus 16x plus 64. Where do I go from here? Why? I'm trying to get x by itself, but since I have an x squared, it's a little harder to get x by itself. What do I have to do? I have to move everything to the same side as the x squared so that I can factor, most likely snowflake. So yes, I'm going to subtract x, and I'm going to add 6 to both sides so that my x's cancel out on the left, my 6 and negative 6 cancel out, and I'm left with 0 on the left. Equals x squared minus 17x plus 70. And this is a snowflake problem at this point. 70 and negative 17. What are my two numbers? Negative 10 and negative 7. Now some people will say, oh, my answers are negative 10 and negative 7. No, my answers aren't negative 10 and negative 7. Negative 10 and negative 7 are what go in the parentheses. Which means what about my answers? They're positive 10 and positive 7 when I end up setting them equal to 0. Do I need to check my answers? Why? Because it's a square root, it's an even index, I do need to check them. So I'm going to start off by checking 10. If I plug in 10, I have the square root of 10 minus 6, and I want to see, does that equal 10 minus 8? Well, 10 minus 6 is 4. 10 minus 8 is 2. Is the square root of 4 equal to 2? Yes, so x equals 10 is good. Now let's try x equals 7. So the square root of 7 minus 6, does that equal 7 minus 8? Well, 7 minus 6 is 1. 7 minus 8 is negative 1. Is the square root of 1 equal to negative 1? No, because the square root of 1 is positive 1. So that answer is no good. My only valid answer is x equals 10. Okay, questions there? Now, hopefully these ones are easier than the 11.2 stuff, because at least there's a process that you go through, so you know you go step 1, step 2, step 3 kind of thing. Okay? All right, let's turn it to the back. There's 2 problems on the back, one of which is solved for you, so let me talk to you about this one first, because it's very similar to the one that we just did. The difference is that this one has a cube root. So instead of squaring both sides, you're going to cube both sides. Now when we squared both sides, we just had to FOIL something. When you cube this side, you actually have to multiply it 3 times. So multiply 2 of them together, and then take that answer and multiply it by the third one. And then it gets a little bit yucky, but you can kind of follow there and check your answers. By the way, do you need to check your answers for that one? No, not if you're confident that what you did was correct, but she does show the check for those 3 answers. So if you want to see one like that, this one's already worked out for you. Okay? But let's look at this guy. What's different about this one? There's 2 square roots. You see that? So if I have 2 square roots, I need to make sure that at least one of them is by itself. Is one of them by itself? So I can go ahead and square both sides. By the way, if they were cube roots, what would I be doing? Cubing both sides. So the square root cancels out the square over here, leaving me with x plus 11. What about on this side? The 3 is being multiplied by this. So the 2, or the exponent, has to apply to both the 3 and the radical. So 3 to the second power gives me 9. And then when I square the radical, I get 2x plus 5. So from here, I would do 9 times 2x, which is 18x. 9 times 5 is 45. Equals x plus 11, and I should have a pretty easy equation here. I'm going to subtract x, 17x plus 45 equals 11. Subtract 45. 17x equals negative 34. X equals negative 2. Do I need to check my answer? Yes. So I'm going to come back and I'm going to say 3 times the square root of 2 times negative 2 plus 5. Does that equal the square root of negative 2 plus 11? Well, negative 2 plus 11 is 9, so this side just becomes 3, right? Over here, 2 times negative 2 is negative 4. And what's negative 4 plus 5? 1. And the square root of 1 is 1. And 3 times 1 is 3. So does it equal 3? Sure does. So my answer is good. Now, I have one last question for you. Where do you think the most likely place is for somebody to mess up in this process on this one? And I'm speaking from experience because I've seen it over and over and over again. Where do you think someone would most likely mess up the process? I'll give you a hint. It's in the very beginning. The biggest place that I see errors in this is people will keep this a 3. Meaning they'll get rid of the radicals, but they will forget to distribute that exponent to the coefficient that's out there in front. Okay? So make sure you're not one of those people that makes that mistake. Okay? Any questions? All right. Happy studying.